Hello everyone. Am I audible?
Yes, ma'am, you're audible.
Yeah, so let's start week 9 doubt session. You can start asking your doubts. So let's start with the activity questions. Anyone has any doubt in this activity? First of all, you have tried solving the questions or not? Anyone has solved the questions?
Yes, ma'am.
Okay, so you have any doubt?
Yes, ma'am.
Okay, which question, which activity?
9.4, question number 4.
Okay. So question number 4 is let x1, x2 up to xn are ID normal mu comma sigma square. An estimator sigma hat square for sigma square is given by this. So find the bias of sigma hat square. Okay, so we have to find the bias of this estimator. Okay, so for calculating bias, we need to calculate the expectation of this estimator, right? Okay, so first of all, sigma hat square is defined as 1 upon n summation xi square minus x bar square.
Ma'am, your screen is not visible.
Is it visible now?
Yes, ma'am.
Okay. Okay, so this is how sigma hat square is defined in the question. Okay, so we have to find the expectation of this estimator first. Okay, so expectation of sigma hat square. Okay, so now expectation of this function 1 upon n summation xi square I going from 1 to n minus x bar square. Okay, now this will be 1 upon n and summation I going from 1 to n, and here expectation will come over xi square. Okay, and this will be expectation of x bar square. Okay, is this line okay
Yes,
for you?
yes, ma'am.
Okay, so now we need to calculate two things here: expectation of xi square. Okay, this is xi, and then expectation of x bar square. Okay, so these two things we have to calculate. So in the question it is given that x1 x2 are following IID normal 0 comma sigma square. Okay, so they are following normal distribution. Okay, so according to which uh, variance of xi, what will be variance of xi? So the formula is this is equal to expectation of xi square minus expectation of xi whole square. Yes or not? According
Yes,
to
ma'am.
the formula.
Yes, ma'am.
Okay, now we can put the value. So what is the variance of xi here? Just see the question. What will be variance of xi?
Um, mu
Variance of xi. So these x1, x2 up to xn, okay, all these xi's are following IID normal with mu comma sigma square. So sigma square is the variance for x1, x2 up to xn. Okay. So
Okay.
sigma square is the variance of xi. Okay. And the mean is, so this we can write as it is, expectation of xi square minus expectation of xi is mu. Okay. Okay, this is given in the question. You can see the x1, x2 up to xn. So in short, we can write it as xi, where I is going from 1 to n. Okay, so these random variable are following IID normal distribution with mean mu and variance sigma square. Okay, now from here we will get the value of expectation of xi square. Okay, so expectation of xi square will be equal to mu square plus sigma square. Okay, is it fine for you? Is this line clear?
Ma'am, can you explain
Yes,
again?
ma'am.
Okay, okay. So, first of all, you need to understand we have x1, x2 up to xn. Okay, or in short, I can write that they are xi. Okay, where I is starting from 1. Okay, 1, 2, 3 up to going up to n. May I write it like this?
Yes, ma'am.
Okay, now you can see that this x1, x2 up to xn, they are IID normal with mu comma sigma square. Okay, so for normal distribution, mu is the mean and sigma square is the
Uh,
variance.
Ma'am, you're
Okay,
breaking. Ma'am, you're not audible.
my screen is visible.
Yes, ma'am.
Okay, my voice is now fine or not?
Yes, ma'am. Fine.
Okay,
It's better now, ma'am.
okay, okay. Sometimes network issue happens, so that's why. Okay, so this okay, so this is we are writing as xi. Okay, so variance of xi will be sigma square. Now is this thing clear?
Yes, ma'am.
Okay, so
Ma'am, I have
variance of
one doubt.
xi is what?
Ma'am, can you explain this up thing, ma'am? The sigma hat square.
Okay,
Is this the formula for
sigma.
method of moments?
No, see, this estimator is given in the question. Okay, this is some estimator for this parameter sigma square. Sigma
Okay,
hat square some parameter, which is sorry, some estimator. Okay, so this is given in the question. Okay,
okay,
and you
ma'am.
have to find the bias of this estimator here. Okay,
Bias is the expectation of theta has minus theta, right?
yes. Okay, that's why we need to calculate expectation of this estimator theta hat square. Okay, that's what we are calculating here. Okay, so we calculated up to this point, and here we need these two values: expectation of xi square and expectation of x bar square. Okay, so we are calculating these two things first.
Okay,
Okay,
ma'am.
so by using this formula of variance, okay, this is the general formula of variance which you have studied.
Yes,
Okay,
ma'am.
we have just put the value variance of xi and expectation of xi. Okay,
Yes,
this is
ma'am.
also given in the question. From here, the value of expectation of xi square will be mu square plus sigma square.
Hmm.
Okay, up to this point, is it clear?
Yes, ma'am.
Okay, next we have to find expectation of x bar square. Okay, so as we have written this formula for variance of xi, similarly we can find variance of x bar. Okay, variance of x bar. So what is variance of x bar? This is expectation of x bar square, okay, minus expectation of x bar whole square. Okay, is it fine or not?
Yes, ma'am.
Okay, now we will put the value of expectation of x bar and expectation of x bar square. Okay, so you can, if you don't know, you can calculate these values as well. Otherwise it's better if you remember it. If you calculate variance of x bar, okay, and variance of x is sigma. Okay, variance of x this is equals to sigma, then can you tell me what will be variance of x bar? You have solved CLT questions and all where we have calculated variance of x bar so many times. So can we calculate it now? Or if you remember it, then you can tell me. Or just calculate it. What will be variance of x bar? Anyone can calculate it? Yes or no? Otherwise, I will solve it.
Ma'am, sigma square by n, I think.
Yes, it is sigma square by n. Okay, I will show you how it is. So variance of x bar. What is x bar? X bar
Is
is
it
the
the
mean.
this thing, last week theory? This thing.
Yeah, it uses those things.
Yes.
Okay, so you should be clear with those concepts also. So x bar is x1 plus x2 plus xn divided by n. Okay, now it will be 1 upon n square. Okay, and variance of x1 plus variance of x2 plus variance of xn up to xn. Okay, now from here it will be n square. Okay, and this will be n times sigma square. Okay, because variance of x1 and variance of x2 up to variance of xn, these are sigma square. Okay, that you can see in the question. Okay, so variance of all these random variable is sigma square. Okay, so this become n times sigma square. Ultimately it will be sigma square by n. Okay, now is it clear?
Yes, ma'am.
Okay, similarly you can find expectation of x bar. Okay, so expectation of x bar comes equals to mu. So I will show you again. So this is x1 plus x2 plus xn divided by n. Okay, so this will be 1 upon n times expectation of x1 up to expectation of xn. Okay, so this is 1 upon n and this will be n times mu. Okay, so ultimately this will be equal to mu. Okay, so expectation of x bar, this is equals to mu. Okay, is this thing clear to everyone?
Yes, ma'am.
Okay, now variance of x bar, which is equals to expectation of x bar square minus expectation of x bar whole square. Okay, now just put the value. So variance of x bar is sigma square by n. This is sigma square by n, and this is something we have to find. Expectation of x bar square. Okay, and expectation of x bar is mu and whole square. So from here the value of expectation of x bar is square, this will be equal to sigma square by n plus mu square. Is this clear to everyone?
Yes, ma'am.
Okay, so we have got the value of expectation of x bar square, this term, and expectation of xi square. Okay, which is mu square plus sigma square. Okay, so now we can just put these two value. Okay, suppose this is equation number 1. Okay, so I will substitute the values. So expectation of sigma hat square, this will be equal to 1 upon n. Okay, and then we have summation of expectation of xi square. So summation, and what is the value of expectation of xi square? This is mu square plus sigma square. Okay, so this is mu square plus sigma square, and then minus expectation of x bar square. Okay, so this value is equal to this term. Okay, so this is sigma square by n plus mu square. Okay. Now, what will be the value of this term? Summation of mu square plus sigma square. What will be the value of this? So sigma square plus mu square. This is constant, and you have to add it n times.
So
Okay.
n times mu square, ma'am.
Yeah. So this will be n times mu square plus sigma square. Okay. And this will be sigma square by n minus mu square. You can just simplify the terms. This n will be cancelled out. This will be mu square plus sigma square by n minus mu square. Okay. So mu square will be cancelled out. Okay. So now we have sigma square minus sigma square by n. Okay. Now we have to calculate bias. So bias of sigma square hat. This will be equal to expectation of sigma hat square. Okay. Minus sigma square. So this value is sigma square minus, okay, sigma square by n minus sigma square. So these two terms, sigma square will be cancelled out. Bias will be minus sigma square by n. Okay, so this will be your answer. You can check the answer. Minus sigma square by n. Yeah, minus sigma square by n will be the correct answer.
Ma'am, can I
Okay.
see the steps of a to finding the variance of x bar?
Yes.
Can you scroll a little bit above, up?
Is this question clear to everyone? Anyone has any doubt?
Um, no, ma'am.
Okay, so okay, so what is the next question you want to ask? Any other question from this activity?
Yes, ma'am. Can we try solve the this thing? 10th question, ma'am. 10th, 11, 12.
Okay. So here let x1 x2 up to xn be IID samples from a distribution with unknown mean mu and unknown standard deviation sigma, and let mu hat is 3 times of this x bar. Okay, be an estimator of mu. So the estimator is given. You have to find bias, variance, and risk of the estimator. Okay, so we have to calculate bias. So what we have to calculate first here?
To find bias, expectation, ma'am.
Yes, we have to calculate expectation. Okay, so tell me what is this? X1 plus x2 plus xn divided by n.
This is the mean, ma'am.
Yeah, this is mean, which we can write as x bar. Okay, so
Yes, ma'am.
mu hat is equals to 3x bar. Okay, can we write it?
Mu hat.
So mu hat is equals to 3 times of x1 plus x2 up to xn divided by n. Okay, so mu hat. So this is what? X bar?
Ma'am, the mu hat is the estimator, right?
Yes, this is estimated.
No, okay, ma'am.
Okay, so this term is what? This is mean. Okay, this is x bar.
3 mu. Yeah, 3x bar.
Okay, this will be 3x bar. Now we have to find expectation of mu hat. Okay, so which will be equal to expectation of 3x bar. Okay, this is what? 3 times of expectation of x bar. Now what is the expectation of x bar?
Mu on itself, ma'am.
This is mu. Okay, so this is mu. So expectation of mu hat will be 3 mu. Okay, now bias, what will be the bias?
Expectation of mu hat minus expectation of this
Okay,
thing.
so this is simply 3 mu minus mu, which will be equal to 2 mu.
2 mu.
Okay, now next is to find the variance.
Ma'am,
So
can I
variance,
screenshot that? Is it possible,
yeah.
please? Done, ma'am.
Okay, so next is to find the variance of mu hat. Variance of mu hat. So variance of 3 times of x1 plus x2 plus xn divided by n. Okay, again this is what? X bar. We can write it like this: 3 times variance of x bar. Okay, so now this will be 9 times variance of x bar.
Yes, ma'am.
Yes or no? Okay,
Yes, ma'am.
now what is the value of variance of x bar?
Mm,
It's better if you remember these things. Variance of x bar, we already we calculated in
it's
the previous question also.
sigma square by 9. And
This will
n.
be sigma square by n.
N. Yeah.
Okay, so it will be good if you remember these two things at least: expectation of x bar and variance of x bar. So it will save your time in the exam. Okay, otherwise you can solve it also, but that will be taking some time. Okay, so variance of is 9 sigma square by n. Okay, variance is 9 sigma square by n. Next is to find the risk of mu hat. So risk is simply this plus variance. Okay, so risk of mu hat, this is bias of mu hat square. First, bias is this whole plus this is 9 6 square by n. Okay, so ultimately it will be mu square plus 9 sigma square by n. Okay, is this question clear? Okay, this
Ma'am,
question last
you are not
4
audible,
mu square
ma'am.
plus 9 sigma. Okay, 1 minute. Am I audible now?
Yes, ma'am.
And my screen is visible?
No, ma'am.
Just give me a minute. Hello.
Yes, ma'am.
Am I audible still?
You're still breaking, ma'am.
Yeah, I already complained about anything with my network. Okay, if you have it, otherwise we can I'm audible and will solve your doubt. Otherwise, ask. Am I audible or my voice is still breaking?
Still breaking, ma'am.
Have any question? Any doubt? Hello.
Yes, hello, ma'am. You're audible now.
Okay. Okay. So, if I'm audible, you can ask your doubts. Otherwise, you can ask your doubts in the next session. Okay, because there is some network issue from my side.
Ma'am, like, can we solve question regarding this thing, method of
Uh,
moments? Just two
yeah.
questions.
Quiz two.
Not quiz two. AQ 9.5. Second question.
Okay, okay. Uh, 9.5.
Second and last question, ma'am.
Okay, and yeah, second is this one. Okay, this is based on method of movements. This question you want to ask?
Yes, ma'am.
Okay. So the density function of a continuous random variable is given, and x1, x2 up to xn be IID sample of x. So find the estimator of theta using method of movements. Okay. So in method of movements, first you have to calculate the expected value of x. Okay. So first of all, calculate the expected value and tell me what should it be. So fx is 1 plus theta x divided by 2 minus from -1 to +1. Okay. So calculate the expected value. Okay, so this is from -1 to +1. This is x by 2. Okay, and then this is theta x square by 2. Am I audible or not?
You are audible, ma'am.
Okay, now we have to integrate it. So this will be x square divided by 4 plus this will be theta and x cube divided by 3 into 2, which will be 6. Okay, and the limits are from -1 to +1. Just solve these two things. Put the limits, these two, and then solve the value.
Is it 0? It cancels out.
So this will be theta by 6 plus theta by 6. Okay. My voice is audible.
Yes, ma'am. It's theta by 3.
So this will be theta by 3.
Yeah.
Okay. And now we have to equate it. So according to this method of movements, expectation of x should be equal to 1 upon n summation of xi. Okay. This is something we did yesterday. Okay. So expectation of x is theta by 3. This should be equal to 1 upon n, and this is what? X1 plus x2 up to xn. Okay. Now we have to find the method of moment estimate of theta in this. Okay, x1 plus x2 in this term. Okay, so from here the value of theta will be 3 times 1 upon n x1 plus x2 plus xn. This is theta at mme. Now you can check which option is correct. So option number B will be correct.
Yes, ma'am.
Okay, now the next question is question number.
Fifth, ma'am.
Which question you want to ask? Okay,
Fifth.
fifth. Yeah. So here, let x be a discrete random variable such that probability of x equals to 1 is this, probability x equals to 2 is this, where p is an unknown. Let x1, x2 up to xn be IID samples from distribution x. Find the estimator of p using method of moments. Okay. So again, we have to find the expected value of x, and we have to equate it with the 1 upon n summation xi, this value. Okay. So find the expected value of x. So here you can see that the distribution is given. X is a discrete
We
random
can
variable. It is taking two values, 1 and 2, and the probabilities are given.
we can multiply them, right, ma'am? For expectation.
Yeah, so it will be, yeah, expectation 1 into this and 2 into this, p upon p upon 2 minus p. So just solve it and tell me what should be the expected value of x here. So this will be 2 minus 2p plus 2p divided by 2 minus p. So this minus 2p and plus 2p will be cancelled out. So ultimately it will be 2 upon 2 minus p. Okay. So this should be equal to expectation of x. It should be equal to 1 upon n summation of xi. Okay. So now this is what 2 divided by 2 minus p.
Yes, ma'am.
Okay. Okay. For ease of calculation, I will let it as m1.
Mm.
Okay. Now from here we have to find value of p. Okay. So just calculate the value of p from here. So this is 2 upon m1 equals to 2 minus p. So from here p will be equal to 2 minus 2 divided by m1. Yes or no?
Yes, ma'am.
Okay. Now you can just put the value of m1. So this is what 2 minus, the ultimate goal is to find it the answer in this term. Okay, so here you can see
Mm.
that this is 2 minus 2 divided by m1 is what 1 upon n summation of xi. Okay, so this is 1 upon n summation x5 means x1 plus x2 up
So
to xn. So this will be 2 minus 2n divided by x1 plus x2 plus xn. Okay, now you can check which option is matching with our answer. So this is option number C.
yes, ma'am.
Okay, so this will be the correct answer.
Ma'am, the maximum likelihood deals with the differentiation, right? And logarithm.
Yes, yes, in maximum likelihood you have to do those things. You have to find the likelihood function, and for maximizing the likelihood function, we differentiate it. Okay, so we take log first. That makes our calculation easy.
For
We take
differentiation
log.
purpose.
Yes. Okay, and then we differentiate it, make it equal to 0. From there, you have to find the value of the estimator.
Okay, ma'am, what about this thing, evaluation of ML estimators?
Evaluation of ML estimator. ML is maximum likelihood.
Okay, ma'am.
Yeah. Okay, any other question you want to ask? Anyone else wants to ask any question?
Ma'am, can you do the fifth question of 9.8? Otherwise, like first question will also be good.
Okay, first one. Okay, so the first question is, you are given a discrete random variable x with this PMF, okay, and we have to find the MLE of P. Okay, so MLE you have to find, so for MLE you have to find likelihood function. Okay, likelihood function is, so first of all, you have to find likelihood of, okay, so I going from 1 to n, okay, and here we have a discrete random variable, okay.
Ma'am, for a continuous purpose, it's different.
Actually, both are same. The thing here is, in a continuous random variable, we have PDFs, right? We have density function.
Yes,
And
ma'am.
for discrete random variable, we have probability mass function. Okay. So you just have to decide according to what is given in the question. Okay.
Ma'am,
If
the
it is a discrete
summation,
random,
yeah, the summation will be over pi only, ma'am.
it is not summation. This is the product. Okay.
Oh,
This pi represents product. This summation is like summing all the
yeah.
values. The pi represents product. Okay. So you have to product the PMFs or the PDFs. Okay. The
Okay.
probability or the densities. Okay. So that you have to do according to the given sample.
Okay.
Okay. So the sample is given. So what we have to do here, here you can see that this is our sample. Okay, now you can see what values we have. So first of all, x is taking these three values, 0,
Yes,
1, 2, and 3. Okay, so this will our sample will also contain values 0, 1, 2, and 3. Okay,
yes,
so
ma'am.
this is our sample. Now here you can see that 0 is occurring two times.
Yes, ma'am. So two times.
Okay, so basically what we have to do, we have to multiply the probabilities for all these points. Okay,
Mm.
you can see in the in this thing, what are we doing? We have sample, okay, I going from 1 to n. Okay, so here you can see that the sample values, the sample points are given to us. Okay, so for each sample point you have to multiply the probability. Okay, is this thing clear?
Yes, ma'am. For every
Okay,
occurrence, we have to multiply, right?
yes. Okay, so now we will put, so you can see, so we have to multiply the probability for all these points. So 3, then 0, then 1, then 2, then 3, like this. Okay, so you can see that for 3 the probability is 1 minus p divided by 3. Okay, for 3 the probability is 1 minus p divided by 3. Now in the sample you can see it is occurring 1, 2, 2 times.
Two times, ma'am.
Okay, so this will get a square. Okay, this will
Yes,
be squared. Okay, next value is 0. So for 0, the probability is 2p by 3.
ma'am. It also got two
Okay,
times, ma'am.
yeah, this is also occurring two times. So 2p by 3, 2p by 3 and whole is square. Next value is 1. So 1 is occurring 1, 2 and 3 times. Okay, so 1 is p by 3. Probability at 1 is p by 3 and whole power 3. Okay, and then for 2, 2 is occurring 1 and the probability is 2, 1 minus p by 3. 2, 1 minus p divided by 3, and it is occurring 3 times. Okay, so this is how you can see we are multiplying the probabilities for all the sample points. Okay, now is this thing clear? How are we calculating the likelihood function?
Yes, ma'am. So after this,
Okay, yeah, so we have calculated this thing. Okay, now you can just simplify this thing. 2 to the power 5 and then 3 to the power 2 plus 2 plus 3 plus 3, which is 10. Okay, which is 5, and 1 minus p power 2 plus 3, which will be 5. Okay, I just have simplified it.
Yes, ma'am.
Okay, now
Understood.
we can take log. So log L, okay, this will be,
Outside. Yeah.
okay, log of 2 power 5 divided by 3 power 10, okay, plus this
Ma'am,
term will be 5 log p.
the constant terms will be
Yes,
outside, right? It's- Okay.
this is the constant term.
Yes, ma'am.
Okay, so ultimately this will be 0, but yeah, I am writing it so that you don't have any confusion. Okay, and then it will be 5 log of
Oh,
1 minus
5
p.
into 1 minus p.
Okay, now we have to differentiate this function.
Ma'am, when do you have the next out session?
Yeah, so the next session will be happening on Sunday, but the doubt session will be happening on Tuesday, next Tuesday. I
Okay.
mean, the upcoming Tuesday.
It'll be for week 9 also. Like a little bit we can cover.
It will be for week 10 actually, but okay, so since this issue is happening today, so you can ask your doubts for week 9 as well.
Okay, ma'am. So
Okay.
you'll be in that session or somebody else?
That is not confirmed now, but whoever is taking session, you can ask your doubts.
Okay, ma'am.
Okay, I will again share my screen. Is it visible now?
Yes, ma'am.
Okay, so we have to differentiate it with respect to p. Okay, then we have log l. So when you differentiate this term, differentiation of this will be 0. Okay, now this will be 5 divided by p, plus
Plus
this
5
will
by
be 5
minus p.
divided by 1 minus p, and there will be one minus sign. Okay, so I will write it as minus, and now we have to put it equal to 0. Okay, so 5 divided by p is equals to 5 divided by 1 minus p. Okay, so from here, so this is 2p equals to 1 will be equal to 1 by 2, which is equals to 0.5. Okay, is it clear to you now?
Ma'am, you're breaking, ma'am.
Can you is my screen visible? You can see my screen.
No, it's fine, ma'am.
Yeah. Just see the solution and let me know if it's clear to you or not.
Yes, ma'am, it's clear.
Okay. Any other question?
Ma'am, which is the important topic of this week?
So in week 9, especially, we have MLE and MME. Okay. So these questions will almost come, like definitely it will come in the exam, MLE and MME. So majorly we have these three things only: MLE, MME, and the bias, variance, and risk of the estimator. So I think I will say every topic is important because it only majorly it has two things. Okay, method of estimation and some bias, variance, and risk of the estimator. It does not include too much topic.
Okay, ma'am.
Yeah. So one of the question will definitely come out of this.
Ma'am, can you tell like how to solve the fifth question? No need of solution. We'll
Oh,
just it's the same way,
okay,
right?
okay. Yes, it will be the same way. So here we are given the density function, okay, because it is a continuous random variable.
Hmm.
So the question is, you have to find the MLE. Okay. So again, you have to like find the likelihood function. Okay. So
It will
likelihood
be
function. Hmm,
it will be like the pi I to n, and
yes.
since it is this PDF.
Yeah. So fx here is theta, k power theta, and x to the power minus theta minus 1. Okay. So likelihood function is the product of all these. Okay. And I going from 1 to n. Okay. So we have to multiply it n times. Okay. So this is something you have to multiply n times. Okay. So theta power n. Okay. So what are we doing here actually is, so this is theta, k theta, and then x1 minus
Mine.
theta minus 1. Okay. Similarly, we have theta, k power theta, then x2 minus theta
Oh,
minus 1. Okay. We have to do it n times. Okay. We have n random variables.
yes, ma'am.
Okay. So this will be up to xn. Okay. Now if you product, okay, if you multiply all these terms, we have n number of terms. Okay. N these terms. Okay. So this will be theta whole power n, and then k power n theta. Okay. And then we have this x1 power theta minus 1, x2 power minus theta minus 1, up to xn power minus theta minus 1. We can write it like this: x1, x2 up to xn whole power minus theta minus 1. Is it correct?
Mm,
They both are equal or not?
they are actually, ma'am.
Okay. Because suppose you have 2 power p, you have 3 power p. You can write it as 2 into 3 and whole power p. Yes or no?
Yes, ma'am.
Okay. So this is, in this way we can write it.
And we just have to apply the log, right?
Yes, you can take log. So this is L. Okay. Now you can take log of L. So this will be n log theta plus n theta log of k. Okay. And then when you take log on this term, it will be minus theta minus 1 and log of product of x1 up to xn. This is theta minus 1. So if you take theta as common, this will be theta plus 1. Okay.
Yes, ma'am.
Okay. Now you have to differentiate it. So this will be del by del theta of log L. So the first term will be n divided by theta. Second will be n log k. Is it clear? Okay. And then next we have minus. So you have to multiply theta with this and then 1 with this. Okay. So this will be
Yes, ma'am.
log of, yeah. So this will be log of
Oh,
x1 up to xn. Okay,
yes.
and when you multiply it with 1, so there will be no theta, so the differentiation of that will be 0.
It'll be 0, ma'am.
Yeah, so is this clear? Is this line clear?
Yes, ma'am. Clear.
Okay, now we have to equate it to 0. So what we have, n by theta plus n log k, which we can write equal to log of multiplication of x1, x2 up to xn. Okay, now from here you just have to find the value of theta. Okay, so you just solve these terms. So this is log x1, x2 up to xn. This will be minus log minus n log k. Now from here you have to find value of theta. So theta will be equal to n divided by log of x1, x2 up to xn minus log minus n log k. Okay, so this will be theta hat Emily. So you can check which option is correct. So option number B will be correct. Okay, you can check n divided by log of product of x1, x2 up to xn and n minus n log k. Okay.
Yes, ma'am.
Yeah, any other question? Anyone else having any doubt? Any other question?
Ma'am, can you check tutorial 1, fourth question?
Variable x being and within sigma square. Let x1, x2 bar be the sample means of two higher sample of x. The expression of x2 bar equals to mu. Mu hat be for mu. Estimator will have biased. Okay, so estimator is given, and you have to find the you have to check whether it is biased or not. So mu hat is a times x1 bar plus 1 minus x2 bar. Okay, so first we need to calculate its expected value. Okay, so this of mu hat. Yes, no. Am I audible? Am I audible or not?
Uh, no, ma'am. I'm just,
Now am I audible?
it's little breaking and your screen is not visible. Now it's visible, ma'am.
Okay. Again, there is some network issue.
Ma'am, it's fine.
So in
We'll.
that question, you just have to,
Yes, ma'am.
yeah, in that question, you just have to find the expected value of x, okay?
Ma'am, and
So you can see that expected value of x,
what does better risk
what is?
means, ma'am?
Okay, better risk means that whichever estimator has less risk.
Okay, ma'am.
Okay, less risk, which will be good, better.
Hmm.
Okay, simply you just have to put the value of expectation of x bar, 1 bar and x2 bar that is given in the question, which is mu. Okay, from there you can just find the value of expectation of mu hat, and then you can find bias.
Okay, ma'am. Yeah, ma'am. Then that's it. My doubts.
Yeah, okay.
Yeah, thank
Okay,
you.
you try solving the question.
Yeah.
Yeah, if you have, then ask it. Okay, thank you. You can leave.